Hi students, today is 16th of April 2020 and we will continue the video on the third module fluid mechanics subject, and we were dealing with Pitot tube in the previous video, and we have seen the derivation of finding the velocity at a particular point in a pipe which is having a fluid flow. What is the velocity we had actually found the equation using Bernoulli's equation. Fine. So if you see, the final equation that we have obtained was equal to the velocity at a point v is equal to cv into root of 2gh. Fine. And your h is the value. What is your h actually? Small h is equal to, it is the height of the rise of the fluid above the pipe free surface. Fine. So that was actually done in the previous class. These are the different arrangements of Pitot tube and the pressure measurement devices that you can have. And you can find h if you are using the differential manometer. Then you can find h using your good old relationship which you used in orifice meter and venturi meter, which is equal to h equal to your x manometer reading into specific gravity ratios minus 1. Fine. So let us get into the numerical concepts, numerical problems. Let us see the first problem, 6.24. So before we start, the problem on Pitot tube are much smaller and much easier compared to the problems on orifice meter and venturi meter, and you are lucky if you get problems on Pitot tube, okay? Because the equation that you need to remember is one or two equation, and easily you can get the answer. Fine. If you see the first problem, 6.24, repeated static tube is placed in the center of a 300 millimeter pipeline, has an orifice pointing upstream and other perpendicular to it. So at 300 millimeter diameter pipe is given to you, and you are placing the Pitot tube at the center of it. Okay. The mean velocity of the pipe is 0.80 of the central velocity. So whatever velocity you get it at the center, okay, because the Pitot tube is placed at the center, whatever velocity you get it, you call that velocity as central velocity. That into 0.8 if you do, you will get mean velocity. Find the discharge through the pipe if the pressure difference between the two orifices is 60 millimeter of the water. So the x, or the what you can say pressure difference is given to you, which is 60 mm of the water. Fine. Take the coefficient of the Pitot tube as Cv, okay, as 0.98. So diameter is given to you. Okay, you have a 300 mm pipe. So convert it into meter, 0.3 meters. Pressure head difference is given, okay, which is equal to 60 mm of water. So 0.06 meters of water. Small h is given to you. Cv value is given to you. Mean velocity is 0.8 times of central velocity. So what is central velocity? How to find it? You have to go for the Pitot tube equation, where your velocity at the center is equal to Cv into root of 2gh. H value you know, okay. Cv value is also given to you, 0.98. If you substitute, you will get the value of the central velocity, which is 1.063 meter per second. So once I get it, I'll find the mean velocity. You call it as v bar or any capital U, anything like that. So that is 0.8 times of the central velocity. So this will be around 0.8504 meter per second. So to find the discharge, area into mean velocity. So pi by 4 d square into v bar. So pi by 4, 0.34 square into 0.8504. So 0.06 meter cube per second will be the discharge. So very simple problem. Similarly, we'll go to the next problem, 6.25. We need to find the velocity of the flow of an oil through a pipe when the difference of mercury level in the differential into manometer connected to the two tappings of the Pitot tube is 100 millimeter. Take the coefficient of the Pitot tube as 0.98 and the specific gravity of the oil is given to you, which is 0.8. So they have given you U-tube manometer reading. In the previous case, they had given you the pressure head difference reading, which was small h. Here they are giving you small x value, which is 100 mm, so 0.1. So to find h, you have to use your good old equation, x into specific gravity ratio minus 1. So specific gravity of oil is 0.8 and the manometer is mercury manometer. So specific gravity of the mercury is 13.6. So proper substitution of all the values will give you the H value. H value will get it as 1.6 meters of oil. So what you need to find, we have to find the velocity. So to find the velocity, we have to go to the velocity equation, which is CV into root of 2gh. So direct substitution, H was the only unknown quantity. You just substituted 0.98 is the CV value. So all substitution will give you 5.49 meter per second as the velocity of the fluid. We'll go to the next question, 6.26. We have a Pitot static tube which is used to measure the velocity of water in a pipe. The stagnation pressure head is 6 meters and static pressure head is 5 meters. See, these are the two new words. Okay, we have never discussed about static pressure head and stagnation pressures, right? So we'll see that. Calculate the velocity of flow assuming the coefficient of the tube is 0.98. See, to find the velocity, I want C, which I know it, root of 2gh. Now h value I don't know. Okay, see, this h is actually the dynamic pressure head. So how to find dynamic pressure head if stagnation pressure head and static pressure head is given to you? Now see that. See, static or stagnation pressure is a pressure. What is stagnation pressure? It is a pressure that is achieved when a flowing fluid or the flowing liquid is reduced to zero velocity by a frictionless process. Okay, so that is what you are doing actually in the Pitot tube, right? You are placing that 90-degree bend and you are taking that point 2 where we are actually assuming that velocity at that particular point 2 is equal to 0 in the derivation. So that is the stagnation pressure that you are achieving. So the pressure inside the Pitot tube is increased only because the kinetic energy is converted into pressure energy. That is what is done. Okay. Now, static pressure is a pressure that is exerted on the body when it remains at the rest. So this is the static pressure. Here you will have stagnation pressure, right? So static pressure plus dynamic pressure will be a stagnation pressure. Okay, stagnation pressure will be the static pressure plus dynamic pressure due to the movement of the liquid. So those both things, if you add, you will get stagnation pressure, right? So using this equation, see, we want the pressure head due to the dynamic flow. That is what is your small h equal to. So small h will be equal to h of stagnation minus h of static. Or in other words, P of dynamic will be equal to P of stagnation minus P of static. So using this concept, we can actually solve. So your h will be equal to stagnation pressure minus static pressure 6 minus 5, which is equal to 1 meter, because stagnation pressure is 6 meter given to you and your static pressure is 5 meter, that is given to you in the problem. So find h, go to your velocity equation, CV into root of 2gh, get the velocity, which is 4.34 meter per second. So directly we will get it. The only thing is you should know that dynamic pressure head is a positive or the difference between stagnation pressure head and static pressure head. If you don't know that, then it will be a big headache to you. So please remember this particular small link between stagnation, static and dynamic pressure head. We'll get into the next question. You have a submarine moves horizontally in the sea and has its axis 15 meter below the surface of the water. A Pitot tube properly placed just in front of the submarine and along its axis is connected to the two limbs of the U-tube containing mercury. The difference of mercury level is found to be 170 nm. Find the speed of the submarine, knowing that the specific gravity of the mercury is 13.6 and that of the sea is 1.026 with respect to the fresh water. So here specific gravity of the water, you have to take it as 1.026, don't take it as 1. Okay. Now X value is given to you. The reading of the manometer is given to you 170 millimeters, so 0.17 meters. Specific gravity of mercury and specific gravity of seawater. Whatever water value is given to you, that you take it 1.026, don't take it as 1. Again I am telling you. Now find the h value. H is equal to x into specific gravity ratios minus 1. So to do the proper substitution, you will get the h value. Find the v value. Fine. So you need to find the speed of the submarine. So v is equal to root of 2gh. So do the substitution, you will get it in meter per second. You want to convert it into kilometer per second. So do the proper conversion. Meters to kilometers divided by 1000. Seconds, you need to convert it into hours. So 1 divided by 60. So 60 goes up here. So 23.01 kilometer per hour is the speed of the submarine Okay, here CV value is not given to you, take it as 1. Okay, now next question 6.2. We have a Pitot tube which is inserted in a pipe of a 300 millimeter diameter. The static pressure in the pipe is 100 millimeter of mercury. Vacuum pressure, the stagnation pressure at the center of the pipe recorded by the Pitot tube is 0.981 Newton per centimeter square. Calculate the rate of the flow of the water through pipe if the mean velocity of the flow is 0.85 times the central velocity. So you need to find the rate of flow. Okay, and the mean velocity is linked with the central velocity by 0.85 times. So we find the central velocity, then find the mean velocity, then we can find the rate of flow, which is A into mean velocity, area into mean velocity. Diameter of the pipe is given to you 300 millimeter, so 0.3 meters. Find the area 5 by 4, 0.3 square, so 0.07068 meter square. Now static pressure head is 100 millimeter of mercury in vacuum. So convert it into meters of water. Okay, don't keep it in mercury. Okay, everything has to be kept in terms of water, head of water. So 100 divided by 1000, I am converting millimeter to meters. Multiply by specific gravity of mercury, you will get in terms of what you can say pressure head in terms of water. So why this negative sign came? Because it is a vacuum pressure. So minus 1.36 meters of water. Stagnation pressure is 0.981 Newton per centimeter square. Convert it into, this is in terms of pressure value is given to you, pressure head is not given. Okay, be very careful. So convert this pressure in meters, 0.981 into 10 to the power of 4 Newton per meter square. Now you find the pressure head. So how to find pressure head? Pressure is equal to rho g h. So h will be equal to pressure divided by rho g, right? So very simple formula which you have used it in module 1. So 0.981 into 10 to the power of 4 divided by rho g, you get 1 meters of water. This is the stagnation pressure. This is the static pressure head. Okay, in terms of water. That is very, very important. Now find the dynamic pressure head, which is stagnation minus static. 1 minus of minus 1.36. So you get it as 2.36 meters of water. Find the central velocity, CV into root of 2gh. So substitute 6.68 meter per second you get. Find the mean velocity, which is 0.85 times of central velocity given to you in the question. So find it, you get it as 5.6678 meter per second. Now find the rate of flow of the water, which is velocity, mean velocity into area of the pipe. Area of the pipe you have found initially, so just multiply these two, you get the rate of flow 0.4006 meter cube per second. So these are some of the 4 or 5 problems that are easy for you to solve, easy to remember. Okay, please look up to go through this particular video. We are almost ending module 3, Bernoulli equation parts. Okay, there is only notches and waves left with this particular what you can say syllabus is left with you. So I will be making daily videos. Please go through the videos. Okay, the link is shared with you in the WhatsApp group, or you can also come to the Google Classroom and see this particular video. Please go through these videos. Thank you. Happy learning. We'll see tomorrow. Okay.